Thanks for checking this out. My name is Patrick Friesen, and I'm the plant scientist here at Biochambers.
Hi, my name is Roman, and I'm an engineering technologist here at Biochambers.
Today we're going to go over chamber maintenance to ensure reliability, experimental success, and reduce the chance of needing service.
Every day that you're using a growth chamber, you should check that it's running with the green light on, either on the chamber itself or connected with VNet. It's also good daily practice to check that all the lights are on as scheduled and that the chamber air temperature matches the set point. If humidity or CO2 control is installed, also check that the actual chamber values are close to the set point. Once or twice a week, maybe when you water or fertigate your plants, you should check the light intensity or PPFD and adjust if necessary as your plants grow towards the lights. If you're unsure how to measure light intensity, check out our video on this. Rotating your plants over the growth area is also good practice once or twice a week if more uniform growth and development is an important goal or part of your experimental design. Before each new experiment, it is important to clean the chamber interior and ensure the water drains are clear. If the floor and walls are visibly dirty, first clean with dish soap and water, and then disinfect with a dilute bleach solution by wiping down all interior surfaces with a soft cloth. When working with bleach, ensure proper ventilation of work area and protect yourself with gloves and goggles. When working with regular household bleach, 5.25% sodium hypochlorite, a 10 parts water to 1 part bleach solution is recommended. If using pool bleach as pictured here, 10.8% sodium hypochlorite, 20 parts water to 1 part bleach is recommended. After disinfecting with bleach, run the chamber at its maximum temperature for 1 day to dry it out. First, make sure the fresh air and exhaust dampers are open to dry out the chamber. Then, to more easily reach and maintain your chamber's maximum temperature, you can close the fresh air and exhaust dampers. This is one application where they can be fully closed. This procedure will help mitigate the risk of unwanted pests and pathogens from attacking your plants. To check and clean the water drains, lift out the chamber floor, then remove any debris, usually an accumulation of potting media. If you have a flex chamber or growth room, it is also important to check the cooling fans of the removable shelves before each new experiment and ensure they are working properly. To check these cooling fans, look here on the front face of the shelves and ensure the LED light is lit when the lights are on. If this light is flickering or off when the lights are on, the cooling fans need to be replaced to ensure longevity of the lights. Every 6 months, all chamber air filters should be cleaned. Air filters are located on the fresh air and exhaust dampers and near the fans blowing into the control panel. Clean filters using compressed air or a vacuum, or by rinsing them with tap water and letting them air dry before putting them back in. Annual maintenance includes checking chamber air circulating fans, sensor calibrations, and the proper operation of high-low temperature limits. Newer equipment has circulating fans that can be checked with our VNet software. To check fan status in VNet, go to the Service area and Miscellaneous tab and look here in the fan RPM area. All active fans should be reading a similarly high RPM and be surrounded by a green box. If the fan RPM drops below 1000, it will turn yellow and red when 0. If fan RPM drops below 1000, it will trigger a fan speed alarm and your fans will need to be replaced. If you cannot see fan RPM status in your VNet software, your circulating fans must be checked visually. Please contact us for how to access the circulating fans in your chamber and be sure to follow all safety protocol outlined in the Operation and Maintenance Manual. Properly functioning circulating fans ensures good temperature control and uniformity and helps keep the refrigeration system running smoothly. Temperature, humidity, light, and CO2 sensors also need annual checks to ensure proper calibration. All chambers have temperature control, and here you can check sensor calibration in tandem with checking the high-low limit temperatures. All chambers have 3 independent temperature sensors, one for chamber air temperature, one for high-low limit temperatures, and one for safety. When the lights are off, all 3 temperature sensors should read close to the same. First, insert a recently calibrated thermistor temperature sensor next to the chamber temperature set point and limit sensors inside the white aspirated sensor box in your growth chamber. Next, turn off the chamber lights and set your chamber to its highest achievable temperature, say 40 degrees. Then, Wait 15 minutes after the chamber has reached 40 degrees and until the sensor has reached stability. Again, closing the fresh air and exhaust dampers helps quickly achieve high temperatures. If the chamber setpoint sensor reads more than 1 degree differently than the recently calibrated sensor, contact us to have your chamber temperature sensor recalibrated or replaced. Repeat the calibration check for the safety temperature sensor with lights off at max temperature and ensure it is receiving proper airflow. Note that when the lights are on, the safety temperature sensor will read 3 to 10 degrees higher than the chamber temperature and limit sensors, as its location is downstream of the lights, which give off heat. Older fluorescent and HID lighting will give off more heat, whereas LEDs give off less heat. If a temperature sensor is disconnected, VNet will show a check sensor alarm, and it will read a nonsense value of minus 327 degrees Celsius. Please contact us for how to access these temperature sensors in your equipment. If all 3 sensors are properly connected and receiving proper airflow, then a 1 degree difference of any given sensor is likely due to a drifted calibration. Confirming all 3 temperature sensors are correctly calibrated and working properly ensures accurate experimental temperature reporting and reduces the risk that the chamber will shut off unnecessarily from exceeding the temperature limits, which is a safety feature of our equipment. Checking the calibration of your chamber, light sensor, and humidity sensor, if installed, can be achieved with similar side-by-side comparisons with other recently calibrated sensors, like the chamber's temperature sensor check. CO2 sensor calibration and spanning requires CO2 scrubbing chemicals and known CO2 concentration tanks, respectively. Please contact us if you are unsure how to check any of these calibrations. Finally, replace the battery in the uninterruptible power supply, UPS, for your chamber's control system every 2 to 3 years, depending on which UPS your chamber has. Turn off and unplug the UPS from its power source, and then follow the manufacturer's instructions on how to replace the battery. Equipment with newer versions of VNet software have a battery maintenance alarm, which will trigger when it's time to change your UPS battery. After reconnecting the UPS with the new battery, reset the battery change date alarm by clicking here in the Statistics tab of the service area of VNet.
Other chamber maintenance not covered in this video includes maintenance related to refrigeration and CO2 control. A qualified refrigeration technician should perform most refrigeration maintenance. CO2 control, if installed on your chamber, can be performed by a lab technician. Details of all chamber maintenance can be found in the Operation and Maintenance Manual. Thanks for watching. Be sure to check out our website and other videos.